Alright, so day 5, ellipses. So, we're talking a little about conics to start, what type of conics we're going to see. We're talking about equations for ellipses, and then we will also talk about graphing them. When we go through the equation part, it's going to be very confusing probably, because you've never seen them before. Once we start doing the examples, hopefully that helps clear those things up. Okay? So don't freak out if you're not understanding it right away. If we do 2 examples you don't get it, then you can start freaking out and yelling at me. Cool? Alright. So, first thing let's talk about what are conic sections. So conic sections are figures that you can take by taking a cone and slicing it into pieces. That's why it's called a conic, a cone, right? So different angles create different types of pieces. If you go straight across that 3D conic where it's got 2 parts to it, we get a circle, right? You get a perfectly round circle. If you take that plane that you're cutting that conic with, you turn it a little bit, you angle it either up or down, we get what we call an ellipse, which is what we're going to do today. We're talking about drawing those ellipses. They're not ovals. And ovals are like egg shapes. These are ellipses. So it's an ellipse. If you take and you cut that plane, you go even higher, you tilt it even higher, and it comes out that top part of the cone, you get what we call a parabola. Hey, have we seen parabolas before?
Yeah.
When?
Before.
Before is it maybe quadratic, which was last unit?
Oh, yeah.
Crazy. So we'll have 3 of these down by today, and the last one's going to be hyperbolas. Or if you take that plane, it goes straight up and down, and it cuts through both the top and the bottom. We get 2 graphs. We get basically 2 parabolas. They're called hyperbolas. That's what we'll talk about tomorrow. We'll be graphing those. So we have 4 conics, circles, ellipses, parabolas, hyperbolas. We've done 2 already. We're doing a 3rd today. Tomorrow with that 4th one. Okay? So those are our 4 types of conics we're going to talk about. So first of all, what shape is this? X squared over 4 plus y squared over 4 equals 1. What type of shape would that make if I asked you to graph that? What if I multiplied both sides by 4 and it became x squared plus y squared equals 4? It's a circle. Right? So if I have numbers that have the same denominator, I can make a circle out of them. Well, what if they don't have the same denominator, like that second one? What if it's a 4 and a 1?
That's not a circle. That's
Appreciate
a parabola.
Yes, Sam.
It's a parabola.
It's not a parabola.
It's another
Oval.
circle.
It's not an oval.
It's another ellipse.
It's an ellipse.
It's an ellipse.
It's an ellipse. So, what happens is, if we have different denominators, one of our axes gets stretched. So a circle is perfect because these are the same. Well, if the numbers are different underneath, we have different lengths here. So it stretches my circle into an ellipse. So that's why that different denominators makes it turn into an ellipse. Okay? Now, there are a couple of vocab words we're going to go through. We're talking about our ellipse. There are 2 axes in the ellipse. There's a major axis and a minor axis. Alright? Which one do you think is the longer one?
Major.
Major, right? Major greater than minor. So, major axis connects the 2 farthest points apart in our ellipse, also called the vertices. I'll close in a second. Minor axis is the shortest segment within an ellipse. It connects the 2 points closest to each other, which are called the covertices. We'll talk about that in a second. So, major is the longest line you can make in the ellipse. Minor is the shortest line you can make in an ellipse. So as stated before, the vertices or the vertex of an ellipse is the 2 points at the end of the major axis. The 2 points farthest away from each other in our ellipse. In this picture, they're along the y-axis because it's stretched vertically, but it may also be stretched horizontally. They can be in the x-axis. It all depends on where the major axis lies. Covertices are the ends of our minor axis, right? The 2 shortest points away from each other. Okay? So, we're going to be asking you when we graph on the notes and probably on the homework, where are the vertices, where are the covertices, how long is the major axis, how long is the minor axis, and we're going to be talking about graphing the ellipse. Now, on the test, I don't think we're going to ask you for all those different things, but it's good at practice, we know how to find them. On a test, I would assume we're just going to give you an equation and be like, hey, yo, graph the ellipse. just like that too, if I word it. No?
You think I
You don't think so? Probably not, you're probably right. So I would assume we're just gonna graph on a test, but we're gonna do all the steps as we go through the examples. Now, equations look like this. We said, what about their denominators? They have to be
The same.
the same made a circle.
I'm
They
sorry.
have to be not different, right? So they have to be different number denominators. Our equation has to equal 1. That's a huge thing. It has to be equal to 1. We can't do anything with it if it's not equal to 1. And there's addition in between. That's how we tell it's an ellipse. Different denominators, equal to 1, addition in between. Right? If there's subtraction in between, we're going to get the hyperbolas, which we'll talk about tomorrow. Gotta be addition in between. Now, if the larger number is under our x squared value, we're going to stretch it horizontally. Our major axis will run horizontally. Well, let's think about that for a second. Which way does the x-axis go? Horizontally, left to right. So if the larger number is under x, does it make sense it's being stretched horizontally?
correct?
Yeah, right? A squared is always the term we'll give to our bigger number. Okay? If a squared is under the y value, the y squared, we're stretching it vertically because which way does the y-axis go? Up and down, vertical. So wherever the bigger number is telling us what my ellipse is actually going to look like. Is it going to stretch horizontally? Is it going to stretch vertically? Alright. Should we maybe try some examples on graph? Okay. The first one. X squared over 9 plus y squared over 4 equals 1. First of all, where's my bigger number? Under x squared or y squared? X squared. X axis goes horizontally, which means it should be stretched horizontally. And my major axis will be along the x-axis. Well, my center is going to be 0, 0. How do I know that? Because it's just x squared and y squared, just like with the circles. If I have just x squared and just y squared, my center is going to be at 0, 0. Okay? So 9 is my a squared, 4 is my b squared. Because we said a squared always goes to the bigger term. If a squared is 9, what is a going to equal? 3. How'd you find that? Took the square root of it, right? So, a squared is under x. And we said x values go left and right. So what I'm going to do is from my center, I'm going to go left 3, put a point, and I'm going to go right 3, put a point. Those are going to end up being my vertices because they're the bigger number. We'll talk about that in a second though. B squared is 4, which means B is 2. Good. Took the square root of 4, I got 2. Now, b squared is under y squared. Y values go up and down. So from my center, I'm going to go up and down 2. And then I have 4 points that I can draw in and make my ellipse. I missed a couple of them, but I tried. Tried my best. Thank you, I appreciate that.
Are you going to take off of the circle?
If it's not perfect, that's fine, as long as it's not like a diamond or a box, right? Try and make it the best you can. If you give a really poor effort, I might take off for it. But like, if you actually try, and I can tell that you tried to make it, hit all the circle, all the points, that's fine. Okay, so we said our vertices, guys, are the 2 points farthest apart. Normally they deal with the a values, right? Well, with my a's I went left and right, so I know these 2 points are going to be my vertices. Well, what points are those? Where is that on the graph? What did you say, Alec?
Negative 3, 0, 3, 0.
Negative 3, 0 and 3, 0. So 3, 0, negative 3, 0. Now, some teachers prefer that you do the vertices and covertices before you graph. I think it's easier if you graph it and then find the vertices and covertices. So you actually see it on the graph.
Do we have to graph it like each point in a specific way?
What do you mean?
Like if we could we have done negative 3 before 3?
Like when you write it out like this,
Yeah.
that's perfectly fine. When you write it out, if you want to put negative 3, 0, then 3, 0, that's fine. Co-vertices then deal with my b value, and that was under the y, so I know that's these 2 points. Well, what are those 2 points?
0, 2, yeah.
So what were they, Cal? I know Cam said them, but what were
0 and 2 and 0 and negative
0, 2, 0, negative 2. Okay, we have one more thing I want to talk about. The length of the major and the minor axis. Well, which one's the major axis? Which axis are we running across there? The x, right?
Oh, I thought.
It would be here, right? That would be my major axis. Well, there's 2 ways you can go about finding it, finding that length. You can either count the boxes, or you can do 2 times a, because I went 3 left and 3 right. 2 times 3 would be 6. So the length of my major axis would be 6. My minor axis connects to 2 co-vertices we found. Same thing, you can either count the boxes, or we can do 2 times b, because I went up 2 and down 2. What's 2 times 2? 4. So the length of my minor axis would be 4. Alright, does that kind of make sense?
Yes.
Should we try one more together?
Yes.
Okay, let's try another one together. This one, x squared over 4 plus y squared over 16 equals 1. My bigger value, is it under x squared or y squared? Y squared, which tells me my ellipse is going to be stretched vertically, because y goes up and down, right? So in this case, 16 is now my a squared, and 4 is my b squared. The bigger numbers always are a squared. Okay, where's my center? 0, 0. It's just x squared and y squared, so it's at 0, 0. Okay, so that's my center. If a squared is 16, what is my a value?
4.
4. Right? Take 16, take the square root of it. Okay. A squared is under y squared. When I have a y value, which way do I go? Up and down. So from my center, I'm going up and down 4. And I'm plotting points. Then my b squared value is 4, which tells me b is going to be 2. I take the square root of it. Well, b squared is under x squared. X's go left and right. So I'm going 2 to the left and right of the center. And once I have my 4 points, I'm going to draw them in. That's not even close. Good try, though. That was all right. Okay, so we have a couple housekeeping things here, right? We got to find our vertices, co-vertices, major axis, minor axis. My vertices, where are those going to be at? The top and the bottom, because we said that's with our a squared, right? It was under y, so my top and my bottom are my vertices. Well, what are those 2 points? What? Well, just 4 and negative 4. Just write that down.
0, 4, 0, negative 4.
0, 4, and 0, negative 4. Good, right? We need coordinate points for our vertices. 0, 4, 0, negative 4. Awesome. Well, what about my co-vertices? They're the left and right sides. They're the part under x squared. Good. 2, 0, negative 2, 0. Okay, well my major axis connects my 2 vertices. How long is it? 8, right? Either count the boxes or do 2 times a. You get 8. The minor axis connects to 2 co-vertices. How long is that? 4. Count the boxes or do 2 times b. Awesome. Does that make sense? Do you have any questions on that?
Thank you.
Okay, go ahead, try the next one, please. Help me out here normally. 13. Alright, I'll give you a couple minutes to try the next one.
Wait.
And we'll go from there.
Square root of 13.
Andrew,
Yes.
did you try the problem?
Okay,
Okay, hurry up.
I have a question.
I have an answer.
Sure.
Hopefully. What's up, man?
So for these, which one?
Well, so you want here, which one's your, where are your vertices?
You know what?
So the first component.
Oh, the bigger value, 5, right? If I go here,
Almost stuck the shit when I thought.
0, well, I go 5. And then I'm gonna go there.
Oh, I know.
5 my major axis right here.
3.6.
I would I think about it. I know.
I love when they put that song at the radio.
Yeah, I ain't gonna do more structure. All they come.
They rent your radio.
I was
So fun.
Probably.
How did you do it if I gave you that as a, like a radius?
Everybody else.
Same thing, right? Do the same thing you did as a circle.
And then the major act.
Alright, keep working. I'm gonna put my answer up here and we can compare answers.
What? Where is college? Where is that?
It's a huge farming.
Is it in Wisconsin? No, I was just talking about up north. I haven't gone to the rodeo in a couple of years, but I just realized that it's kind of big. It's a really small town.
Today, he just was forcing it.
What's the square root of?
Is he actually flipped?
No. It's all the way across.
Do I have to put parentheses?
Okay, so guys, check it out. That first one's up on the board, right? If a squared is 25, my a value is 5, because that is under my y squared, I'm going up 5, and I'm going down 5. B squared is 16, which means b is 4. Because b squared is under x, I'm going left 4, and I'm going right 4. I'm drawing it in. My vertices go with a squared, so they're at 0, 5, 0, negative 5. Covertices, negative 4, 0, 4, 0. And the length of the major is 10, length of the minor is 8. Question. Yes, you must put parentheses because they are points. Any other questions on that first one? Go ahead and try the second one then, please. Yes, I know square root of 13 is not a nice number. When you start doing vertices and covertices, you better be using simplified radical form. However, when you're graphing or doing length of minor or length of major axis, I will accept decimals.
Oh, what? Wait,
What's the square?
I told you what if it's
Like
not
3.64.
John, what'd you do that?
Simplified radical form.
Is it actually
Oh,
3.64? Oh, I'm a genius. Mr. E,
Yep.
I just guessed what the square root of 13 was.
Let me guess. It's 3.6.
4. I know if it's in second.
Oh, good work, man.
Yeah.
and it's rounded.
Big boy, bro.
I don't like doing I don't like doing this. It's just 13. Nothing goes in 13 is a ball.
What's the square
You
root?
remember that?
Huh?
No, Friday.
I'll tell you about
I know.
2.8. Mr. E,
Yep.
you got any batteries?
Batteries?
AAA batteries.
I do not, man. I'm sorry.
Whoa.
Vertices are a little bit more.
5, 6.
Wait, no, vertices are the axes. Wait.
So you want it to like,
No,
you want
it's the
it
bigger
written
than
like
like.
that.
Oh, boy.
Sorry. Oh my gosh. Bang, 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 bang.
So, those,
For vertices, I want the exact points. For the length, I'm okay with having that rounded decimal.
Wait, what did you do?
Okay?
Zero? No,
okay,
it's
well,
the simplified.
that's gonna be it, because I don't remember how to.
So guys, once you're finished, you can check your answers with mine.
Square root of 2.
Right, just like I said before.
And then I'm not gonna wear those.
Simplified radical form for vertices and co-vertices, please. Decimals are okay for finding lengths. Are there any questions on that last problem? No?
9.
9. Good use of German calc.
That's all I know.
Alright. Then, quick reminder. Quick recap. If x squared is being divided by the larger number, my major axis lies horizontally on the x-axis because it's being stretched horizontally. If y squared is being divided by the larger number, it's being stretched vertically, and our major axis will lie on the y-axis. Alright? So, hey, last thing. The 3 reasons we can tell that it's an ellipse. Looking at the equation. What is one of them?
X squared plus y squared equals 1 with uneven numbers on the bottom.
Okay, so you listed all of them. Can you do just one at a time?
My bad. Equals 1.
Equals 1. That's a big first one.
Different numbers on the bottom.
Different numbers in our denominators. That's the second one.
Yeah.
And it's plus. It's addition in between. Very good. Swipe up, subscribe, like, and comment.